First thing we're going to talk about is that the red circles are carbons. There are hydrogens, there are oxygens, there are other atoms, but we are specifically focusing on the carbon atoms. We're worrying about numbers of carbon atoms in this particular reaction, and I'm not going to confuse it with all the other stuff. Okay so far? So red circles are carbon atoms. What do you notice about the carbon dioxides that are coming in? There are 3 of them. Does that matter at all to us? Miha's nodding her head yes. There are 6 in the equation, right? 6 carbon dioxides go into photosynthesis. This is saying that only 3 are going in here. Miha?
Because since you said it's a cycle, it goes more than once.
Since it's a cycle, it goes more than once. All right? Calvin cycle happens twice in one photosynthesis reaction. All right? For every 1 glucose, the Calvin cycle has to happen twice, has to turn twice. Nick?
Hey, but if it goes twice, won't you end up with 12 oxygen every 3 O2?
No, because the O2 aren't coming out of the Calvin cycle. Where did the oxygen come from?
The inside.
Oh,
The water.
The water, right? The oxygen comes from the water, not from the Calvin cycle. These oxygens that are on the carbon dioxide, they're staying with the carbons. I'm just not drawing them all in. All right? So this is just a very simplified picture of the actual chemistry.
Then it's a lot of oxygen as it keeps going and just getting more oxygen and it's not leaving.
No, because it does leave. Some of it does leave. It'll be okay. I promise. It'll be okay. I'll show you. We're gonna.
Oxygen does come out.
Yes, but not in oxygen form. Just oxygen atoms come out of this in another form. I'll show you. Don't worry. We're going to start right here. All right? So we have 1, 2, 3 molecules. Everybody's good with that so far? 3 molecules, and each one has 1, 2, 3, 4, 5 carbons. So we have 3 molecules of 5 carbon. Good so far? Those 3, right, are going to join our CO2s that are coming in. And it's probably easier if right here I point out the fact that a molecule that was 5, all right, from what we started with, is going to pick up a 6th carbon from the carbon dioxide. And you'll have 3 of them. So each carbon dioxide attaches to 1 of these 5 carbon molecules. So you wind up with 3 6s. Lost anybody yet? Anybody lying? How?
So that would join up with the 3 one that's coming in, right?
This one joins one of those. And then this one will join another one. And this one will join another one. Right?
And what happens to the O2?
O2 stays attached. It stays attached. It's still there. I'm just not drawing it all in. So, how many carbons total would we have right now? 18, right? So we've got 18 carbons. This form of the molecule, not stable. All right? It won't stay in the 6 carbon form. So it reshuffles. Everything just kind of like shuffles around, moves around. And what happens is that they wind up splitting in half. And you wind up with 1, 2, 3, 4, 5, 6, right? So now you have 6 molecules of 3. Still 18, right? Just instead of being 3 groups of 6, now it's 6 groups of 3. Simple math. Nobody's lost yet. Nobody's lying. All right. But this particular form of the molecule doesn't work for glucose. if this is what the molecule stays as, glucose will never be made. It needs to be rearranged. And what did we say last class that energy is used for, or that energy is, what its whole purpose is? Breaking and combining molecules, right? Breaking bonds or forming bonds. So in this case, we've got ATP and NADPH. Where are they coming from? From stage 1. Good. We've got these two energy molecules that come in, they release their energy, all right? And supplying that energy breaks the bonds and reshuffles everything, all right? Breaks these molecules up and rearranges them. Now, in this picture, it probably looks like they look the same. It's still 6 groups of 3, what the heck? The easiest way, and it's not this easy, but to make it simple for you guys to just kind of get your questions answered, it would be like me saying, this is carbon atom number 1, this is carbon atom number 2, and this one is number 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Get the idea? They're all in order. When the energy gets supplied, those molecules get rearranged, and now maybe they're in a 2, 1, 3 pattern. All right, so it's still the same amount of molecules, they're just in different places. And because they're in different places, they create a different shape, and therefore they are a totally new molecule. Good? So the energy gets supplied from stage 1 to reshuffle our molecule. Now we're in a form that can be used for glucose. 1 of our 6 is going to drop off. All right, it's going to leave the Calvin cycle. Easy way to think of this molecule right here is think of it as being
Now,
that. What is that?
Half of a glucose.
Half of a glucose. Half of a glucose. That molecule right there is half of the glucose that we're looking for. All right, it's pretty much half. Phosphate will leave. All right, will be released. So now we've got 5 molecules of 3 carbons, right? Which is how many? 15, right? So we've got 15 now. But those 15 are not in the form that we need for recycling. It's a cycle. We need to reuse and reuse and reuse. So, more energy is supplied. Where's that energy coming from? Stage 1, ATP from stage 1. Oops, stage 1. This ATP is going to come in, break the bonds, reshuffle again, and we're back to 3 groups of 5. Lost anybody yet? So we've got half of a glucose, but we've only used half of our CO2s. So we're going to do the whole process a second time to get the second half of the molecule. Then those 2 halves can combine and make the whole. Make sense? So if we go through,